Sometimes your polynomial will be in a special form. Special forms include a difference of squares, a difference of cubes, and a sum of cubes. So for each of these special forms, I have a formula written out that will help you factor that particular special form. So in example 5, we're going to factor a few polynomials that are in one of these special forms. So let's start with example A. Our polynomial is 36x squared minus y squared. This is a difference of squares. So how do you identify a difference of squares? Well, first of all, you have to be subtracting. Difference means subtraction. So we have our subtraction sign there, but you have to be subtracting squares. So when you look to the left of the subtraction sign, you can kind of take the square root of this guy. So the square root of 36 is 6, and then the square root of x squared is x. So basically, if you take 6x and you square it, meaning you multiply 6x by itself, 6 times 6 is 36, and x times x is x squared. Okay, so essentially we took the square root of 36x squared and we got 6x. Okay, so that means this guy, 36x squared, is a square because there's something out there, namely 6x, that we can square to get it. On the other side of the subtraction sign, we also have a square. You can square y to get y squared. Okay, so we are subtracting squares. Okay, that's what a difference of squares is. And it factors very easily. Okay, so we're going to break this into something times something. Okay, and you have to keep the order. Okay, so the 6x is going to have to go on the left inside each pair of parentheses. Okay, and then the y is going to have to go on the right. And as far as the signs are concerned, you need one of each, a plus sign and a minus sign. And that's it. We're done. We factored it. Okay. You could have also written, done your 6x on the left and the y on the right. You could have definitely put the subtraction sign first and the plus sign later. Okay. Both of those are correct. But that is how you factor a difference of squares. You basically take the square root of the term on the left, you take the square root of the term on the right, and then when you set up these pieces inside the parentheses, you keep them in the correct order, and then you're going to have a sign of each, one plus sign and one minus sign. Okay, you can multiply this back out to check yourself if you wish. Okay, so let me go ahead and box this. Either of these is a correct form. Okay, let me try again. I'm having trouble with my pen. So here we go. All right, so let's look at the next one in part B. So in part B, our polynomial is 49 minus 9x squared. This is also a difference of squares. Okay, I'm subtracting, and when I look at the term on the left, I can square 7 to get 49. And then if I look to the right of the subtraction sign, the square root of 9 is 3. The square root of x squared is x. Okay, so that's what I square, 3x. If I square 3x, I get 9x squared. Okay, so this is confirmed to be a difference of squares. So it's very easily factored. Write down your factors. You have to keep the order. Do not feel like the x has to be on the left side. Okay, here the 7 has to go on the left, and the 3x has to go on the right. And now we can go ahead and put our signs, one of each. Okay, again, this is equivalent to 7 minus 3x times 7 plus 3x. Either is acceptable. Okay, we're done. That's it. You can multiply it back out. Check yourself. You should get 49 minus 9x squared if you multiply it back out. Moving on to part C. We've got x squared plus 25. Okay, so this is a sum of squares. I'm not subtracting. I'm actually adding here. I know I square x to get x squared, and I square 5 to get 25, okay? So you might be thinking, well, this is going to factor very similarly, okay? The issue is, if you go back up here, look under the special forms. Notice we don't have a formula for a sum of squares. We have a formula for a sum of cubes, but we don't have one for a sum of squares. Reason being, a sum of squares does not factor. You can't do it. Okay, so I'm just writing that right there as a reminder that if you encounter a sum of squares, you won't be able to factor it. Okay, so coming down here, x squared plus 25, you cannot factor this guy. It's not possible. Okay, only a difference of squares. All right, part D, 8x cubed minus 27. Okay, this is a difference of cubes. So you're going to identify it in a very similar fashion to identifying a difference of squares. I am subtracting, and then on either side of the subtraction sign, I have something cubed. So essentially, think of taking the cubed root of each of these guys, okay? The cubed root of 8 is 2, and the cubed root of x cubed is x, okay? Meaning if I take 2x and I cube it, that means I multiply 2x by itself 3 times. 2 times 2 times 2 is 8. X times x times x is x cubed. Okay, so the cubed root of 8x cubed is 2x. 27 is also a cube. Okay, the cubed root of 27 is 3, because if I take 3 and multiply it by itself 3 times 3 is 9, times 3 is 27. Okay, so this is a difference of cubes. We can go up and look at the formula for doing this, okay? It's written in terms of a u and a v. Okay, so I'm going to go ahead and jot this formula down, okay? So we are told that u minus v cubed, or sorry, I wrote it wrong. We are told that u cubed minus v cubed is equal to, your first factor is going to be u minus v, and then the second factor is going to be, you're going to take your u, you're going to square it, you're going to take your v, you're going to square it, okay? This last sign will always be a plus, and then to get the middle term, you're basically going to multiply these guys together. It's going to be your u times v, and for the first sign in here, you're going to change the sign. So in the first factor, we have a minus, so we're going to change it to a plus. Okay, so again, this sign right here is always positive, and this sign will be opposite the sign in the first factor. The sign for the first factor is coming from here. Okay, so this one is kind of tough to remember, so if you just want to kind of memorize the formula, that works too. Okay, so how do I identify the u and the v? Okay, so the u here is going to be 2x, and the v is going to be 3. Okay, because this is really 8x cubed minus 27 is the same thing as 2x cubed minus 3 cubed. Okay, so that makes the 2x your u and the 3 your v. Okay, so again, we can write this out. Okay, if we're doing 8x cubed minus 27, that's the same thing as 2x cubed minus 3 cubed. Okay, so then just follow the recipe. You're going to write down your u minus your v, and then you're going to multiply by the other factor is going to be u, which is 2x. You're going to square that. And then you're going to add the u times the v. And then your last piece here will be plus a v squared. Okay, so you are going to have to clean this up. All right, it is very much following a recipe. So this is going to be 2x minus 3, and then the other factor, we have to square 2x. Okay, you have to square everything in the parentheses. Remember, you're doing 2x times itself. So 2 times 2 is 4. X times x is x squared. And then we're going to have plus 6x plus 9. Okay, so that is how that particular thing breaks down. Okay, so now, we are supposed to factor completely. Okay, this guy is not going to factor again, but I do have a feeling this guy is going to factor. Okay, so let's take a look here. 2x minus 3, we're going to leave it alone. Okay, when we concentrate on 4x squared plus 4x squared plus 6x plus 9, there is no common factor that we can take out. Okay, you would have to follow the procedure to factor ax squared plus bx plus c. Okay, if you do that, you should get, this one's kind of easy. 4x squared is going to break down into 2x times 2x. And then positive 9 breaks down into 3 times 3. And then since everything's positive, both signs are going to be positive. Okay, so that's what this one is going to look like. And you can actually, multiply it back out here. 2x times 2x is going to give you the 4x squared. 2x times 3 is going to give you plus 6x. And then, ooh, look, this is why you should check yourself. I get another 6x. That's going to give you 12x, and then you'll get the 9. So it actually doesn't factor this way. So I was wrong. See, I make mistakes too. Okay, I think this may be as far as you can go. So I'm going to go ahead and box this as the answer. I don't think, now that I've looked at it, I don't think that 4x squared plus 6x plus 9 factors. Okay, always check yourself. Even I check myself when I'm factoring just to make sure you're right. It's 30 extra seconds to multiply it back out to make sure you did it right. All right, one more. Okay, this last one is going to be a sum of cubes. Sum means you're adding. Okay, and on either side of the plus sign, we have something cubed. The cubed root of 64 is 4 because 4 times 4 times 4 is 64. The cubed root of x cubed is x. And then the cubed root of 125 is 5. 5 times 5 is 25 times 5 is 125. The cubed root of y cubed is y. Okay, so we have a sum of cubes here. Okay, you can't factor a sum of squares, but you can factor a sum of cubes. Okay, their formula is up here for you to follow. Okay, again, we have to identify the u and the v. Okay, so let me come down here and write down the formula. So u cubed plus v cubed is going to be 2 factors. The first factor, you're going to write down the cubed roots. So it's going to be u and v, and you're going to retain the same sign. Okay, and then for the next factor, okay, you're going to square these guys. So you're going to have a u squared and a v squared. The last sign is always going to be positive. Okay, to get the other sign, you're going to swap it with this guy. Okay, so the opposite here is going to be minus, and then you need to multiply the u and the v together. Okay, so that's the formula. This is your u, this is your v. Okay, so if we write this out, 64x cubed plus 125 y cubed, that is the same thing as 4x quantity cubed plus the quantity 5y cubed. Okay, follow the recipe. So this is going to be u, which is 4x, plus v, which is 5y, times the u squared, so 4x quantity squared, minus u times v, so 4x times 5y, plus v squared, so that's going to be 5y quantity squared. Okay, clean it up. This is going to be 4x plus 5y times, okay, 4x times 4x is going to give you 16x squared. This is going to be minus 20 times x times y, plus, if you do 5y times itself, that's going to be 25y squared. Okay? All right. That is how this particular thing factors. Again, you can multiply it back out and check yourself. Okay? I might actually do that here because I haven't multiplied out one of these guys that has had a cubic. Okay? You have more terms, but you can still do the box method on it. So if I have 4x and positive 5y, I'm still going to make a column out of that. And then I'll do 16x squared, negative 20xy, and then a positive 25y squared across the top. And I'll go ahead and make a box. Okay, so like this. And let's break it down further here. Oopsie. I really need to get my pen fixed. It needs a new part. Okay, so that's good. And then here. So it's just going to be a bigger box when you multiply this out. All right, so we're going to take each pair. Okay, so 4 times 16 is 64. X times x squared is x cubed. Okay, 4 times negative 20 is negative 80. X times x is x squared, and then we multiply that by y. 4 times 25 is 100. X, y squared. And then 5 times 16 is 80. We've got x squared times y. 5 times negative 20 is negative 100. We've got x times y, which is y squared. And then lastly, we've got 5 times 5 times 25, that's 125. Y times y squared is y cubed. Okay, again, across the diagonals, you have like terms. So those are like terms. These are like terms. I know we have two variables here. Like terms are going to be the same variables raised to the same powers. So you can combine anything with an x squared y. You can combine anything with an x times y squared. Okay, so I've highlighted the like terms. Notice they cancel. You've got a positive 80 x squared y and a negative 1, so those go bye-bye. You've got a negative 100 x y squared, which cancels with a positive 1, and we are left with positive 64x cubed plus 125y cubed, which is what we started with. Okay, so this is how the special forms work.